You ready? Let's learn some math. Math, 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 math. Math, 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 math. Math, 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 math.
Come, take a journey with us each Monday from 5:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters. Welcome to another episode of Math Matters. I'm your presenter, Mrs. Tisha Hughes Thornhill. Today, we're going to take a look at vectors. But before we begin vectors, let's take a look at our challenge question from the previous episode. Our challenge question read, given matrices L and M, calculate LM and then M inverse. Let's begin by taking a look at LM. So just a reminder, LM is just matrix multiplication, and so we are going to multiply matrix L by matrix M. And so we do our first row, first column, 1 times -5, which is -5, plus -1 times -5, which is +5. Second column, 1 times 2 is 2, plus -1 times 3, which is -3. -2 times -5, +10, plus 0 times -5, which is 0, so 10 plus 0. -2 times 2, which is 4, plus 0 times 3, 0, -4 plus 0. 4 times -5, which is -20, plus -2 times -5, which is +10, so -20 plus 10. 4 times 2 is 8, plus -2 times 3, which is -6. And then, of course, we just work those parts out. So -5 plus 5 is 0. 2 plus -3 is -1. 10 plus 0 is 10. -4 plus 0 is -4. -20 plus 10 is -10. And 8 plus -6 is 2. And that completes the first portion. And so we look at the second part of the question, which was M inverse. A reminder that the inverse of a matrix is equal to 1 over the determinant of the matrix times the adjoint of the matrix. So let's begin. So we're going to look at our matrix M, and we're going to find the determinant. And so we're going to be looking at the diagonals. So -5 times 3, which is our AD, and that's equal to -15. And then we'll look at the next diagonal, which is 2 times -5, and that's -10. And so we have our determinant. So 1 over the determinant times the adjoint. The adjoint is the first shall be last, the last shall be first. Change the signs of the other two. And so our 3, which was last, is now first, etc. So let's simplify. -15 minus -10, when those two signs come together, it means to add. So in essence, what we have is -15 plus 10. And so that becomes -5. So 1 over -5 times the adjoint. And also as a reminder, this is now an example of scalar multiplication. And so that fraction is going to be multiplied to every part of matrix well, the adjoint of matrix M. So negative 1/5 times 3, negative 1/5 times negative 2, negative 1/5 times 5, and negative 1/5 times negative 5. And that is our final answer for the inverse of matrix M. I'll just read it. Negative 3/5, 2/5, negative 1, and 1. Now that wasn't so difficult. When we return, we're going to take a look at our lesson for today, which is vectors. Don't go anywhere. We'll be right back.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboardofelucation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education. For more information, visit our website at www.abboardofelucation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Welcome back. Well, how do we use vectors? Vectors are used to locate places, objects, and individuals. They are also used to describe the behavior of people and objects subjected to force. A vector is a quantity that has both magnitude or size and direction. Aircrafts are given instructions by the control tower involving direction and distance as they take off and land. Another example of vectors: acceleration. Acceleration is also a vector quantity because it has both magnitude and direction. One that we should be familiar with, but I'm going to now make the connection to vector. Here we have a map of St. John's. The streets in the city are mainly one-way. This is a visual of vectors as the streets are varied magnitudes and show direction of the flow of traffic. A force applied to an object is also a vector as it has both a magnitude and a direction. Finally, we'll take a look at communication. Communication is another great real-world example of vectors and how we utilize them in our real lives. Communication between countries involve messages moving various distances in many directions. Stay tuned. We'll be right back after these messages.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboardofelucation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education. For more information, visit our website at www.abboardofeducation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Welcome back. As we continue, we will need to remember that a vector is a quantity that has both magnitude or size and direction. Let's begin with the representation and notation. So vectors are a convenient way of describing how to get from one point to another. Here we have a visual representation of a vector. Vectors have a tail, which we can call the start, and a head, which shows the direction, and there is an endpoint. The length of the vector represents its magnitude. Vectors are denoted as, for example, AB with an arrow at the top. Without the arrow, AB would be a line segment instead. This is represented as a column matrix XY. Starting from the tail of the vector, the X value tells you how far left or right to go, and the Y value tells you how far up or down to go. Here we have a grid and just a random line, and we'll call it AB, and the vector would look like this. So it has to have an arrow, whether at the head or on its body, just showing the direction. So let's look at that same AB, and because it is called AB, that means A would be considered the start and B the end. So in order for us to come up with the position vector, we would need to count the spaces to show the direction. And of course, because our X value comes first, we are going to move left or right before going up or down. So when we start at A, naturally, based on the position of B, we are going to go to the right. And in this case, it's to the right 7 places. And then we are going to move upwards to B, and we would have moved 4 places up. And so this vector is going to be written as 7, 4. Just a reminder, we went to the right 7 and up 4. Those were both positive directions, and so our result is positive. Now let's turn it around. What if it were BA instead? So of course, B would now be the start, which therefore means our arrow is going to have to point in the direction that we want the vector to go to. So BA, B is the start, A is the end. And again, because our X value comes first, we need to consider whether we're going to be moving left or right. And so we know that we're going to the left, and it's to the left 7 places. And then we would have moved downward, and it is down 4 places. And so our vector is going to be -7, -4. Just a reminder once again that this column matrix is a way for us to express our vectors, and it tells us how to move. And so we would have gone left 7 places and down 4 places. Let's try this out. Here's another vector AB. What's the position vector? What would the matrix look like? Well, let's start. A would be the start, and so we would go to the right 1 place, and we are going down 1, 2, 3 places, and so this vector is going to be 1, -3. Let's look at another example. This time we have CD. C is the start and D is the end. How do I get from C to D? Well, I'm going to be moving to the left. Let's count the places left. 1, 2, 3, 4, 5 places. So we would have moved 5 places to the left, which therefore means our x value is going to be negative 5. And we're going to go upwards 1, 2 places. So our position vector is going to be negative 5, 2. Let's take a look at one final example following this pattern. So we have here, we would probably want to say EF, but if we take a look at the arrow, we would notice that F is actually the start and E is the end. And so this is FE. So given position vector FE, what would that vector as a matrix, as a column matrix look like? Going from F to E, well, did we move left or right? No. And so that value is going to be 0. However, we did go upwards, and we would go up 1, 2, 3 places. And so this vector is going to be 0, 3. Let's pause for a quick commercial break.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboardofelucation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education. For more information, visit our website at www.abboardofelucation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Welcome back. Now let's take a look at equal vectors. Well, I hope that word equal sounds familiar to you, because that's literally what we're going to be looking at here. Vectors may be having different names, but having the same magnitude and direction. So two vectors are equal if they have the same magnitude and direction, which implies the vectors are parallel, because if they have the same steepness, it means they'll never cross. So they are in fact equal vectors, and so therefore can be considered parallel as well. So continuing, let's take a look at AB. Well, what would AB be described as? We would move to the right 1 and down 3. This is our vector from previously, right? So that's 1, negative 3. And let's take a look at PQ. Well, PQ would have moved to the right 1 and also down 3. Now, we already knew they were equal because we would have talked about the definition of what it means to be an equal vector. And so it's safe to now say that AB is equal to PQ, which is equal to 1, negative 3. And that's pretty much it for equal vectors. Once they have the same magnitude and direction, they are considered to be equal. Moving on to the inverse vector. Now, this is just another fancy way of saying going in the opposite direction. And so AB is going upwards, but if we look at the next vector, QP, QP is going downwards. Let's look at AB. We'll move to the right 1, 2, 3 places, and then we would go up 1, 2 places, and so that is 3, 2. QP, however, we are going to be moving to the left 1, 2, 3 places, and down 1, 2 places. So this therefore becomes -3, -2. Now, what does it mean to be inverse? So let's compare AB and QP. AB is equal to 3, 2, which if I look at QP, QP looks similar to AB except there are some negative signs there. So if I say negative QP, that would therefore mean that it is equal to AB. Why? Because a negative times a negative gives you a positive. And so if I multiply that scalar, which I would hope that you would have identified from previous matrices lessons, that the scalar, if I multiply that negative into the matrix, it could be understood as even a -1. So -1 times -3 is +3, and -1 times -2 is +2. And so QP, if I multiply that by a -1, is equal to AB, or AB is equal to negative QP. And so the reverse would also be the same, or be true. So if I looked at the QP and I made AB negative, that would also be true. And that is because they are inverse vectors. Let's move on to multiplying these vectors now. So given another vector AB, determine vector PQ, which is 2AB. So you were already given the position vector AB. They want you now to determine PQ, which is twice AB. So let's start with that information. PQ is equal to 2 times AB. Well, we already know what AB is, which is 3, 2. And so we can just rewrite that now as a scalar multiplication. 2 times 3 is 6, and 2 times 2 is 4. And so when we multiply AB by 2, we get 6, 4. But we're not done there. We're going to now place this on our graph. So we choose any point and call it P. So that's the point that I would have chosen. Now, how are we going to find out where Q is supposed to be? Well, we need to use our position vector 6, 4. So it tells us that we need to move to the right 6 places and up 4 places. So let's move to the right 6. 1, 2, 3, 4, 5, 6. Now we need to go up 4 places. 1, 2, 3, 4. And so that point there is where our Q is going to be located. And so for us to have our vector, we'll just connect those 2 points, and we have to be sure to place our arrow in the direction of the vector. So that should be pointing upwards. So these 2 vectors are similar vectors, but we would have multiplied AB by 2 in order to get PQ. So in other words, PQ is twice AB. What if we had a similar question, but this time we were given the 2 vectors and asked to state the relationship between the pair of vectors on the grid? Well, we have AB, but we're going to need to actually find that because we weren't given any other information about it other than the diagram. So we need to come up with that vector. So we move to the right 1, 2, and down 1. So that becomes 2, -1. And we have to do a similar thing for PQ. So we count from P, 1, 2, 3, 4, 5, 6 places to the right. And now we need to go down 1, 2, 3 places. And so this would be 6, -3. Now, how are we going to decide the relationship between these 2 vectors? Well, we need to make a comparison. What we have are 2, -1 and 6, -3. And so if I take the numbers in the similar positions for each matrix, 2 and 6 are in the same position. And so if I divide 2 into 6, I get 3. And I can do the same for the second position. So negative 3 divided by negative 1, negative into negative is positive, and 1 into 3 is 3. So it's safe to say that PQ is 3 times AB. Let's check. 3 times AB was 2, negative 1. 3 times 2 is 6. 3 times negative 1 is negative 3. And there we have PQ. But is that the only way that we would have had to come up with this? No. We could have actually made the comparison in the other direction. And so this time, let's look at it as 2 divided by 6, which we know is going to be equal to 1/3. And taking the second position, negative 1 divided by negative 3, likewise, negative into negative is positive, and so that is equal to 1/3. And so it's safe to say that AB is 1/3 of PQ. Now let's check and make sure that's true. 1/3 PQ, PQ was 6, negative 3. If I divide 3 into 6, I get 2. And if I divide 3 into negative 3, I get negative 1. And so that should be 2, negative 1. And that's pretty much it for multiplying a vector by a scalar. We're almost done, but let's hear a word from our sponsor. And when we return, we'll continue.
The Board of Education is responsible for the funding of scholarships, awards, and bursaries within Antigua and Barbuda. In keeping with our mandate, interested individuals who are citizens or nationals of Antigua and Barbuda are invited to apply. Application forms are available online at www.abboardofelucation.com and should be completed and submitted on or before the last working day in April of each year. Scholarships are available for those wishing to pursue an associate's, bachelor's, or master's degree locally, regionally, and internationally. Individuals reading for PhDs are also supported. We are the Board of Education. For more information, visit our website at www.abboardofelucation.com or call us today at 463-9025, 463-9026, 463-9027, or 463-9028.
Welcome back. Now, we did quite a bit, so let's put it together by taking a look at a practice question. We have here a graph with 2 vectors on it, vector OA and vector OB. So let's read the question. The diagram shows 2 position vectors OA and OB. Write as a column vector in the form XY. First, write the coordinates of the following points. So we need to figure out what's the location of point A. And so let's begin. So we'll start from O, because O happens to actually be our origin, which is 0, 0. And we'll move to the left 1 and up 1, 2, 3. So we went to the left 1 and up 3 places, and so our coordinate is going to be -1, 3. Now I hope you notice the difference between a coordinate and a vector. The coordinate goes horizontally and is separated by a comma, and a vector goes vertically and has no other symbols in between, no commas, no lines, no nothing. So our coordinate for A is -1, 3, and is written as seen on the screen. Now let's do a similar thing for B. So we'll start at O, or 0, 0. We move to the right 1, 2, 3, 4, 5 places, and up 1, 2 places. So this coordinate is going to be 5, 2. Let's take a look at B, the next part of the question. So there's a reminder at the top of our coordinates for A and B. Part B wants us to write as a column vector in the form xy. OA is our first question. So let's look at OA. Now, we've already done the work in terms of the direction, the movement, to finding where A was located. But this works in terms of the coordinate in comparison to the vector because the origin was 0, 0. And so we can just take our coordinate and place it into a vector, which is negative 1, 3. Likewise for B, OB, same thing. So 5, 2, because our origin was 0, 0. Now I point this out because our origin is not always located at 0, 0. So remember, a vector tells us how to move. And so while in this case the coordinate corresponds with the vector, it is not always the case. So just be careful and be mindful and remember what coordinates are and what vectors are and how they work. Now, part B has another part where they want us to write BA as a column vector in the form xy. But do we have BA on our graph? No, we have point A, we have point B. So this therefore means we need to now draw this vector. And it goes from B to A. So B is our start and A is our end. So let's connect those 2 points. Right? And remember, a line is just a line if it does not have that arrow on it, which therefore makes it a vector showing its direction. And so we're going from B to A. Now the reminder from our previous answers is on the top of the screen, and this is going to help us to find BA. So when we look at what we have here, we have OBA or OA. So O is our origin. Following our arrows, it says that we're going from O to B, and B continues to A. But when we look at the other direction, O goes to A, and it stops right there. And so we can say that O is the beginning or the origin, and A is the end, because that's where everything ended if we follow the direction of the arrows. So with this, we actually need to now be able to label our sides. Now, because O goes to B and then to A, we will call OB side 1 and BA side 2. And that's because we're thinking of the direction, the beginning point and the ending point. But when we look at OA, we're not going to call that a side, but that is actually going to be called the resultant. And the resultant is just another way of saying the shortcut, if I were to explain it any other way. So if we start from home and we're trying to get to some point, which that point is A, how can we get there? We can follow along the street, or we can take the shortcut, maybe through a pasture. So it really just depends on the situation. We can put multiple scenarios to something like this. So side 1 and side 2 shows the continuation, and the resultant shows the shortcut. So the resultant is equal to side 1 plus side 2. And we know that that is true because O was the start and A was the end. And if we look at side 1 and side 2, it still gets us to the same destination, which was A. Likewise, we can reshuffle this formula and say that side 1 is equal to the resultant minus side 2. And the side really doesn't matter which one you call 1 or which one you call 2. But as long as they are identified and you use the corresponding vector for the appropriate sides. So BA, when we look at our diagram, BA is actually identified as a side. And so it means that we're going to be using the latter formula, which is side 1 is equal to resultant minus side 2. But since BA was called side 2, that's what we're going to look at. So side 2 is equal to resultant minus side 1. Well, what is the resultant? According to our graph, the resultant is OA. And we're going to minus side 1, which is OB. Okay, so now let's replace those with their column matrix, their respective column matrices. So OA is -1, 3, and we're going to minus OB, which is 5, 2. So -1 minus 5 and 3 minus 2. -1 minus 5, just a reminder again, signs are the same, so we add and keep the sign, is going to give us a -6. And 3 minus 2 is 1. So that becomes -6, 1. And this would be the completion of that question. But what if we weren't sure if our answer was correct? We'll be able to check that. So let's try by counting our spaces, because we know that that's how we can also find our vector. So if we go from B to A, we count left 1, 2, 3, 4, 5, 6 places. So we went to the left 6 places and went up 1 place. We'll realize that our answer was in fact correct. And so -6, 1 is our final answer. Just a word of caution. Now we are practicing for CSEC, and so please pay attention to the amount of marks the question is worth. Something like this can be worth 2 marks. And personally, if it is worth 2 marks, I don't think it's enough for us to just count the spaces. That's something that we can use to check our answers. And so what we would have done previously by identifying our 2 sides and resultant and utilizing the formula is what would be recommended. So this brings us to our challenge question for this week. So the diagram shows 2 position vectors, OC and OD. Write as a column vector in the form XY. Part A, write the coordinates of the following points, and they are labeled there, O, C, and D. Part B, write as a column vector in the form XY, OC, OD, CD. Now, please remember what we would have just done. Everything that we would have done is important as it pertains. And notice that this time for the challenge question, our origin is not 0, 0. So be careful. So this is our final challenge question for this segment of the season. So hopefully you've been like Britannia Bucknell, who's been participating regularly, and we really await your submissions. So please participate. Now's the time, it's not too late. We really appreciate your commitment for joining us Monday after Monday and participating in our challenge questions. Remember to send your submissions to mathmatters268@gmail.com. Once again, our email is mathmatters268@gmail.com. While that was our final challenge question of the season, we actually do have 2 more episodes pertaining to CSEC math. And so we would like to invite you to join us next week, where I will be presenting test-taking tips and strategies, particularly for paper 1. Have a good evening. Thank you for joining us.
Come, take a journey with us each Monday from 5:30 p.m. on ABS TV. Let's get to the heart of the matter. Math matters.